So the structure is going to be very similar to acid, bases and salts. उस chapter में you took acids, bases. You studied about what happens if acids react with metals. What happens if they react with so and so thing. Here also it's going to be the same. So you'll start off with an overview of how do you identify metals and non-metals, like what are they like when you touch them, what are they like when you see them, all of that stuff. And then you'll have chemical properties. Okay, what if we put metal in an acid? What if we put metal in water? Like, what are they going to react like with different substances? Okay, and then in the end, things specific to acid spaces was pH. In this case, you're going to have, like ionic compounds and some additional notes about it. Okay, so that is like the overall overview of the chapter. So before you start, okay, this is something that you guys need to be very comfortable with, like this whole year, about the valency, whether it forms cation, anion, and what valency a particular element has. So that's what I've been telling you guys right from the beginning. Keep practicing that Quizlet set, about different valencies, what kind of ions it forms and all. Okay. Okay. So coming to first part, which is basically the physical properties of metals and nonmetals. So just whenever you come across physical properties, it means that physically speaking, physical matlab, if you're just looking at it, with your five senses, basically, if you look at it, what does it look like? Is it shiny? Is it not shiny? Is it a solid, liquid, gas? What color it has? When you touch it, is it hard? Is it soft? So all of these basic things come under physical properties, like melting point, boiling point, color, physical state, that sort of things. Chemical properties are how does it change at the chemical level, like what sort of reactions it undergoes. Okay, so this is the basic difference between physical properties and chemical properties, just like physical change, chemical change. Okay. So this whole chapter will be talking about metals and non-metals. Can you guys identify any common metals that you know of?
Sodium.
Iron.
Yes, iron. Yes.
Zinc, aluminium, copper, silver, gold.
Okay. Yeah, so these are the metals, especially like silver, gold, copper, aluminium, iron. You would have like used them also, right? What about non-metals?
Oxygen, rubber, plastic, glue.
Oxygen, yes, it's a non-metal. Rubber,
Plastic.
yeah, so they're non-metals in that, yeah, they are not metals. But in this context, we'll be looking at elements that are not.
Diamonds.
Oxygen, yes. Diamonds, yes.
Carbon.
Carbon, yes. How all, like, there is one, where do you use carbon? It is something that you've used for years and years.
Graphite and diamonds.
Oh yeah, diamonds, yeah, if you have diamond jewelry, yes, you've been interacting with carbon.
Graphite. We use for
Where did you
pencils
come
and
across graphite?
Pencil.
Where?
pencils.
Even while breathing carbon.
Where?
Even while breathing.
Breathing. Do you breathe carbon, like direct carbon?
We breathe oxygen, give out carbon dioxide.
No.
Yeah, you breathe in oxygen. Yeah, like you breathe in compounds of carbon, like carbon dioxide and all. Yeah. Yeah, if you're breathing in smoke, then there is a chance you would have breathed in carbon. Yeah. Smoke may you have the black particles, right? Like smoke has a color purely because there's like tiny particles of carbon there. So that's another form of carbon. So carbon and oxygen and whatever air major gases you have, that's like the most common non-metals you've come across. Apart from that, there's iodine is a non-metal, sulfur is a non-metal, phosphorus is a non-metal. Phosphorus also, you guys have interacted with it. You just didn't know that there was phosphorus in it. So you can find phosphorus
Matchstick?
in matchstick. That is correct. Yeah. Okay. So that is white phosphorus. You find it in the matchstick. That is why matchstick you're able to like light it just by just doing this frictions there. Okay. So yeah, some common metals and non-metals. So if I take some coal is a form of carbon. And if I take, let's say, a block of iron, like an iron nail, what are some obvious differences that you guys can figure out between coal and this thing? Oh, before that, Neki says helium in balloons. Yeah, if you play with balloons, there is helium inside it. That's a non-metal, that's elemental. That's a good example. Okay, but coming back to it. So coal is a non-metal, iron is a metal that you guys are sure of. But how did you identify that iron is a metal, coal is a non-metal? Like what
Ma'am,
makes
because of their physical properties and chemical properties.
chemical properties? Like you won't start doing experiments with iron and coal, right? So let's talk about physical properties here. So how did you identify that, oh, this block, this metal is, this like iron nail is a metal, but this is a non-metal?
First of all, luster.
Very nice. Luster is a word you used. What do you mean by luster?
Conducts electricity.
Heat
Shininess
surface.
of a metal.
The shine of a surface or something.
Absolutely. Very nice. Luster is the shininess. Puneet has mentioned shiny, solid, hard. So coal is also a solid.
Malleable.
So what is the difference that you find between iron and coal?
Malleable.
Ductility and malleable. Yeah.
They can be drawn into sheets.
Ductile.
Very nice.
Ductility.
Ductility. Okay, these are all like
Conductivity.
Sonorous.
that we don't use like while talking normally. So what do you mean by malleability?
Drawn into
Property that
sheets.
It
makes
can
them
be drawn into
convertible
thin sheets.
by hammering.
Yes. Beaten into thin sheets. Malleability is the ability to be deformed. Like thin sheets, you can like make them into different shapes. Yeah, ability to be deformed. Thin sheets is like
Solidity.
one of those things. What do you mean by ductility?
It can be drawn into wires.
Wires.
Thin wires, yes. So if you pull it apart, it's gonna like stretch like chewing gum. Chewing gum is ductile. Yeah. Okay. Nice. I think, and then you said conductive.
Sonorous.
Sonorous. Very nice. So first, what do you mean by conductivity?
Allows
The
electricity or
amount
heat
of
to pass
heat
easily
they
through
can
it.
conduct.
Conductivity is
To
the
pass anything.
Contain free
ability to
electrons.
conduct.
Basically.
Like what is conduct? What do you mean by conduct?
Passage. Easy passage of
Correct.
heat or electrons.
Yes. So the ability.
Passing of electrons.
Yes. So conductivity is the ability to pass, and then you have different types of conductivity. As Nikki says, there's conductor of heat, conductor of electricity. So electrical conductivity is one thing. Heat, if you're talking about heat, thermal conductivity is one thing. Yes. And Aditya, you said sonorous. Okay, what do you mean by sonority or sonorous? Something being sonorous.
The
They make
sound.
a ringing sound when struck.
Yeah.
They produce a ringing sound and struck hard.
Very nice. Where have you guys come across this kind of sound? Like,
Ma'am, the
In the
when we
temple.
yeah, in the bars also.
temple, yes. Where else?
Electric bells.
Bells, yes.
But they're irritating actually.
It is. And
Ma'am, when the bars are there and when we struck them with a stick
like
also
gate or
on doors.
may, right?
Yeah.
And even as kids, like I don't know how many of you were mischievous, but if anybody has like taken like a spoon and a plate and start hitting
That is also
that, yeah. So the annoying
And
stuff
last year
that
only.
that is sonorous. Yes, sonority. Yeah. Cool. So these are like some of the physical properties. Very nice, you guys listed them out. Let's revise all of them. I'll write it down. You guys also note this down. So physical properties of metals. Okay, so the first one is luster. Okay, so let's do a quick revision. Anirban, what do you mean by luster? You can say it in your own words, Anirban. Like if you can't recall it.
They are drawn into, ma'am, they are drawn into wires.
No, luster.
Ma'am,
Ma'am, there's shiny appearance.
Shiny appearance. Yes, the shininess. So note it down, write it down, write the thing. One moment, I'll just finish this. Luster is the shininess. Okay, next. Yeah, Aditya, what's up?
ma'am, for answering.
Oh, okay. Tell the second property. Okay, second property. Whose turn? Dhruv.
Yes, ma'am. Malleability.
Malleability. Okay. And definition of malleability?
They can be beaten into thin sheets.
Yes.
Ability to be drawn into sheets.
Be beaten into sheets. Awesome. Next, Elena. Another property?
Ductility,
Yes. And definition?
the ability of a metal to be drawn into wires.
Very nice. Ductility is the ability to be drawn into wires. Okay. So both of the malleability, ductility might sound similar, like one is sheets, one into wires, like what's the difference? Different shapes, right? But the thing is, malleability is the ability to be deformed. Like if you hit it with a hammer, it's not going to break. It's going to just form a dent in the metal itself. Okay. So that kind of
conductor.
Sorry, Neki, what's that?
Also for ductility, it should be a conductor of electricity.
No, ductility is different from being a conductor. So that's what I'm getting into. So malleability is the ability to be deformed. So if you like hit it, if you press it with a hydraulic press, if you hit it with a hammer, it'll just be deformed. It's not gonna shatter into pieces. So that, it not breaking out, but just getting deformed, like Play-Doh is malleable. Okay. Ductility is, this is also kind of being deformed, but in a different way. Like if you are pulling apart like a block of metal, eventually it's going to
Electrical wires.
Yeah, it's not gonna break. Like Play-Doh, if you have played with modeling clay or like made shapes with clay or putty or whatever, if you take it apart, it just like breaks and comes apart, right? But chewing gum, if you like pull it from opposite sides, it's going to like stretch and stretch. So that ability to just stretch is ductility. The ability to be deformed without breaking is malleability. Okay, so that's like the difference. It's not just the shape of being thin sheets and wires. That's kind of it. And both of these are because metals have something called high tensile strength. So just make a note of it. Tensile strength is basically like metals can, if there's a block of metal, like it has a very good strength. Like if you bend it, if you take a wooden stick and if you bend it, it's just gonna break, right? But if you take a metal rod and bend it, it's not gonna break like a wooden stick, it's gonna bend, right? So that is because of that shows the tensile strength. Like it can stretch itself, it's just not gonna break. Yeah. Cool. So we talked about luster, malleability, ductility. What other properties?
Hardness.
Metals are hard, yes. Okay, next. Mansi.
Ma'am, sonorous.
Sonorous, yes. And what does that mean?
Ability of a metal to produce a ringing sound.
Yes. Sonority or being sonorous is the ability to produce ringing sound. Specify when struck, like they don't produce it on their own randomly. That's going to be a problem if they do that. But
When struck hard.
when struck. Yeah, so the ding sound, like they just continue, just doesn't stop. Okay, then two more properties. Either we can write it as two separate properties, or we can write it under a single umbrella. Which is the one that we're missing?
Conductivity.
Conductive.
Awesome. So conductivity, what does it mean? Divya? Divya Gandhar, are you there? Oh, I made a spelling mistake here. Conductivity होना चाहिए. Divya. Divya is not here. Can any of you, like whoever is Divya's friend, can you, any of you just message him and check what's up with him? In the meantime,
Ma'am, he is there.
like I know he's here, but he's not responding. Network issue hai, or is he just not at the computer? Kya ho raha hai? In the meantime, who can mention, like just put it in words, what do you mean by conductivity? Puneet?
You called me, ma'am. Yeah. Miss, as I told earlier, conductivity is the easy passage of electrons or the heat particle.
So ability to pass electricity or heat through them. Okay, here make it specific, like note down this also. If it is ability to pass electricity, then what sort of conductivity is it?
Electric conductor.
Electric conductivity or electric conductor, yes. And if it is the ability to pass heat,
Thermal conductor.
thermal, yes. Okay. So if you observe, like whenever you come across the word therm, then automatically associate it with heat. So thermal decomposition is, if you heat it, tabhi decompose hoga. Thermometer is measurement of heat. So like, these are some easy tricks. You know, if you come across a new word, you can figure it out based on what it is. Awesome. Okay, so these are like the physical properties of metals. Non-metals in general don't show them, but always, as always, like there are certain exceptions to it. Okay, so some exceptions, okay, we'll take it one by one. So metals show luster, non-metals don't. Like case in point, you can see like coal is not shiny. Even if you take like sulfur or phosphorus, like head of a matchstick is not shiny, like the way metals are, like the way,
Remember, iodine is.
Yeah, but there are some other non-metals that show luster. Yes, iodine is a good example, Aditya. What others?
Diamond.
Diamond.
Very nice. Yes. So exception for luster is iodine and diamond. So let's call it exceptions in non-metals. Okay. So I'll show you how. Diamond, yeah, like you can see it. So this is what iodine, like one form of iodine. Like if you come across iodine crystals, you can see they kind of look like metals here. Guys, what's happening? Are you noting down? Are you looking here? Like I can't tell.
Yes, I'm looking here.
Okay. Then what can we talk about? Malleability, ductility, well, I don't think there's any exceptions as such. Like all metals are malleable, ductile. Some of them are really malleable, some of them are less malleable. Like the ability, like the extent of it changes.
Aluminium is highly malleable, and gold and silver.
Yeah. So ductility, basically, usually you can say copper, gold, and silver are like the highest. Actually, malleability also, like gold and silver are extremely malleable. Aluminium also to some extent. Ductility, copper has like one of the highest ductility, along with again gold and silver. Like special points about them. Okay. When it comes to hardness, again, which is a non-metal that's like extremely hard?
Diamond.
Diamond, yes.
Diamond.
Yes. Diamond is extremely hard. Like you cannot break or cut a diamond. You can only use another diamond to do it. Nowadays, yeah, there's like synthetic materials. You can't use any element for it, but yeah, there's like silica based, like synthetic materials you can use to cut it. But elements mein, yeah, diamond is the hardest known substance on earth. It's the hardest element on earth. Yeah. Another exception to it. So non-metals may hardest is diamond, but all metals are not hard. There are some metals, there are some soft
Mercury.
metals.
Sodium.
Sodium.
Sodium is a soft metal. In fact,
And potassium.
yeah, all the metals that are around sodium, that are that are close to sodium in the periodic table, or that are similar to sodium, are all soft metals. So even potassium is soft. Even
Mercury.
Mercury is like a liquid, yes. But yeah.
Sodium and potassium can be cut with a knife.
Can you repeat that, Nikki? Sodium and potassium can be?
Cut with a knife, right?
Yeah. all of these, like sodium, potassium, lithium, all of these can be cut with a knife. And not just, you don't even need like a really sharp knife. You can take your butter knife, you can take a spoon, and you just need to put a little force on it and you can like cut it.
Miss, what is CS?
CS is cesium. So it is the most reactive metal in the whole periodic table. Yeah. So yeah, like even magnesium to some extent is kind of, no, it's more like malleable than soft. I'd say you can bend it easily. Yeah.
Ma'am, can you please show the last slide
What? Which?
for a second?
The physical properties. Okay.
Yeah, 1 second.
Hardness may, again, exceptionally hard metals like lead is like really hard. Yeah.
Diamond can also come, right, in hardness.
Diamond is a non-metal. That's why I mentioned it as an exception here, right? The diamond is the hardest non-element. In this case, since we're talking about physical properties of metals, I was putting down like extreme metals, like highest, lowest, that sort of thing. Okay. So here we're talking about exceptions in non-metals, but yeah, because metals may be exceptions here. Like usually we say hard metals are hard, but there are some metals that are not hard. That's why I've like just mentioned here. These are like the exceptions. Okay, what is the next thing? Sonorous. All metals generally are sonorous. We don't really have any metal does not show it. Conductivity. Again, is there an exception to conductivity? Any non-metal that can conduct either heat or electricity?
Graphite.
Very nice, yes. Again, it is graphite. So basically, elementally, yeah, carbon is the exception. In the form of graphite, it's a good conductor of electricity. Okay. Yeah. So these are like the basic.
Graphite symbol, what did you give? G or C?
Which one, Nikki?
In the bracket.
Graphite ka symbol is C. Graphite is basically carbon, no? Just one form of carbon. I'll just mention this symbols for others also so that you guys are familiar with it. Diamond ka symbol kya hoga elementally?
C.
C. Diamond is also carbon, just a different form of carbon. Iodine would be I. Iska symbol is I. Okay, so this is sodium, Na, potassium is K, Li is lithium.
Ma'am, G is what?
This is mercury.
Okay.
The stuff that's there in your thermometers. And CS is cesium. Okay. Let me know when you guys noted it down. Actually, can you guys come on video? And where is Divya? Divya is not here yet. Any of you had messaged him?
No.
Guys, either be on video or like,
Ma'am,
yeah. Hi Devya, what
miss, I
happened?
cannot hear you. Hello.
Hello. Am I audible?
Ma'am, I think he should rejoin again.
Yeah. Simple stuff like अगर कुछ video audio दिख नहीं रहा है तो you should immediately talk about it. Okay. Cool. So Nikki is done. Aditya is done. Oh, you're still writing. Okay. Elena is done. Anirban is done. Mansi is also done. So Puneet and Dhruv, yes, let me know. Is
Miss,
that
I'm done.
you, Puneet? You raised your hand.
Miss, done.
Okay. Cool. So Divya also said he's copied the things and he's rejoined. All right, coming back to this. Let's see. Luster, malleable, ductile, sonorous, melting point. Okay. Let's talk about melting and boiling points. What do you think melting and boiling points of metals would be? Like really high, really low, somewhere in the middle?
It will be high, but less
Really
than
high.
the
Very
Really
high.
high.
Fractions.
So that's another point you can note down. So melting points, like metals usually have really high melting and boiling points. But again, what would be the exceptions there? Oh,
Mercury?
Mercury.
Mercury, yes, absolutely. There are a couple
something
of
with
others
that.
also.
Ma'am, mercury is liquid at room temperature.
Yes. Melting point is high.
There's other also that comes just above
Gallium.
30 degree. Yeah, gallium.
Dhruv, what did you say?
Gallium.
Gallium, yes, correct. So exceptions in melting point are, mercury is liquid at room temperature. And you have gallium. So Ga is gallium. So gallium is weird. What happened, Puneet?
Ma'am.
So gallium is weird in that its melting point is somewhere at near 30 degrees Celsius, like 31 or 33 or something like that. So during summers, or if you put it in your hand, yeah, it'll start melting. But if you just like leave it alone, and if it's, if the room temperature is below 30, if it's like winters, or if it's a really cold country, then it's going to be solid. Okay. But yeah, it is one of the low melting things. Cesium, CS, that we had come across over here, that also has a low melting point. So that also like what happened?
Ma'am, the spelling of cesium is CAE or CES?
Both are used. Like I've come across both the spellings. Both are fine.
Okay, ma'am.
So cesium is the one that's used in atomic clocks to that measure like precisely what 1 second is. That's an element there. But yeah, cesium, just like gallium, has low melting point. Like you hold it in your hand and it starts melting. If you leave it alone, yeah, it's like solid. Yeah. So these are like 3 of the metals that have low melting points. Yeah. Then physical properties, yeah, sodium and potassium. Oh, this is interesting. So sodium and potassium, if you generally like look at them in a laboratory, they don't appear shiny. But if you like cut a fresh piece out of it, like the inside of them, the metal itself is actually lustrous. So why are sodium and potassium like not very shiny in general?
They are highly reactive, so they would already have reacted with oxygen in air.
Very nice. Absolutely, Nikki. So sodium and potassium, like, do you guys remember the reactivity series? Where are sodium and potassium?
Potassium is the most reactive.
Top two.
Top two, right? Yeah. Please call me or whatever it is. Like, yeah, sodium and potassium, it's like the top two most reactive metals. So they're so reactive that if you just keep a piece of metal like outside, they are going to react with whatever is around them. So atmosphere, say oxygen, say they'll react. Water vapor, say they'll react. Carbon dioxide, say they'll react. So yeah, because they're always reacting with things, they lose the shininess because there's like a layer of impurities on them. That is the reason sodium and potassium, whenever you see it in a video, in a laboratory, anything, they are taken out of a liquid. So they are usually stored under kerosene. Like either kerosene is most commonly used, but otherwise any kind of oil. Yeah. Metals are usually hard. Exceptions are sodium, potassium can be cut with a knife, and these are liquid. We discussed this. Malleable. So we can see an example of malleability is aluminium foil. Even like medicine covers, right? So medicine covers, you can see that this is really shiny. So it's like a metallic thing. So yeah, so malleability is coming into picture here. Thin sheets of metals being used.
Also, ma'am, on sweets, there are thin sheets of gold or silver.
Yes, nice. That is like ultra thin. That's a very good example. Yes. Ductile, gold, silver. You've got like thin chains. You've got like wires, electrical wiring, all of that stuff. Good conductors of heat. Where do you use this property of metals being good conductors of heat?
Wires.
Electric heaters, ovens.
Nice. Somebody said wires. Like, why do you want to conduct heat through wires? Where are you using that?
No, sorry, not heat.
Yeah, but cooking vessels, yes, you cook in metallic vessels because that can get heat from the flame to the food. Okay. Where else do you use metals being good conductors of heat? This property. Cooking is one. Where else?
Ma'am, electricity, like it conducts electricity.
Electricity, Choddo, bhai, we're talking about good conductors of heat, no? Puneet said heaters, yes. Space heaters, water heaters, yeah.
Oven.
Oven, yeah. Microwave, this is not the property. You're literally blasting it with something called microwaves. Okay. But yeah, other heaters like solar water heaters, even like
the cake pans, like cake pans we put.
Cake pans, yes. Cooking vessels. Yeah.
Toasters.
Which one?
A toaster.
Toaster, yes. Yeah, if at all you get a chance to look inside your toaster, it's lined with metal which start glowing orange, like when it's heated. That's how it cooks the bread. Yeah. Okay. Excellent. Iron, yes. When you're ironing clothes, yeah. We haven't discussed where do you use the property of luster in metals?
Gold jewelry for like decorative housing.
Decoration, yes, like jewelry and all that makes it shiny, looks good, absolutely. But there is a functional use for it.
I wanted a number of Sigri Global Grill. Sigri Global Grill.
Yeah. What about it? Oh, he got disconnected. Array. Okay, but luster kahan pe use hoga? It's a functional thing, not just a decorative thing. I'll give you a hint. Like you guys studied light chapter, no? So you should be able to get it from that.
Mirrors.
Reflecting surfaces because they are smooth.
Yeah. So yeah, absolutely. Like the property of metals being lustrous is used in mirrors. So luster is nothing but whatever light is falling on them, it's getting reflected back. Like that's why we see it as being shiny. And mirror is basically a glass slab, and the piche wala part is given a coating. Like usually silver used to be used in the olden days, but these days, yeah, they're using something, you know, less expensive and yeah, something better. Yeah, but absolutely, mirrors may the luster is used. Yeah. Okay, now coming to good conductors of electricity. Yes, you guys have mentioned conductors of electricity, lots of uses. So electrical wiring, anything to do with electricity, you use metals, even in like chips and wires, chargers, everywhere. And sonorous also we discussed, used in making bells. Exceptions also we've discussed everything. Cool. So that is all the details of metals, like physical properties of metals versus non-metals. Okay. Now, before we get to the chemical properties, I want to discuss one thing with you guys. So we've seen how metals and non-metals can be. Yeah, Neki, what's up?
Can you go back to the previous writing screen for a minute?
Oh, okay. Here. This one?
Yes, ma'am.
What happened? You still noting something down?
The last point, melting point.
Okay. Cool. In the meantime, again, everybody has like disappeared. What happened? Where are you guys? Okay, by the time.
For now, we have to write till here only, right? For now.
We discussed, yes, physical properties and all the exceptions. So if users may, if there's something that you didn't get, like something that you wouldn't have gotten, then make a note of it so that you don't forget about it. If there was something new to you. Okay. All right. So before we get to the chemical properties, I want to discuss the fundamental difference of why or how metals are different from non-metals. Okay. Where is the difference coming from? Like, why do metals have luster, sonorous, malleability, all of that, but non-metals don't have that? So to figure that out, I need you guys to do an exercise, okay? So give me examples of metals. Okay, some things we discussed was sodium is a metal, potassium is a metal. Yeah, Dhruv? Yeah. Magnesium is a metal or a non-metal?
It's a metal.
Metal.
Magnesium metal.
Oxygen, you said, was a non-metal.
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 Ferrous.
Which one?
Iron, zinc.
Iron, zinc, they're all metals. Let's take aluminium.
What about boron?
Boron is, oh, that's a good point. So there's some more elements like boron, silicon, and a few more, arsenic. So, and there's few more also. So all of these, selenium also, I think, all of these come under something called metalloids. So metalloids fall between metals and non-metals. So some properties they share with metals, some properties they share with non-metals. Like for example, silicon At room temperature, it does not conduct electricity, which is like a characteristic property of nonmetals. But if you cool it to sufficient temperatures, right? Like if you cool it below freezing, I don't remember exactly what temperatures, but on cooling it, it suddenly starts being able to conduct electricity, which is like a property of a metal. Okay. So yeah, so there's like, they fall exactly in between metals and non-metals. They share some properties with metals, some properties with non-metals. In different situations, they sometimes behave like metals, sometimes like non-metals. So they are classified as something called metalloids, between metals and non-metals. Okay. But yeah, this chapter will be focusing mainly only on metals and non-metals. Okay. Aluminium is a metal, then oxygen is a non-metal, carbon is a non-metal. What about like
Nitrogen.
nitrogen is a non-metal? Absolutely.
Fluorine.
Chlorine is a non-metal. Okay. 4E.
Hydrogen.
Sulfur, yes. Phosphorus.
Sulfur.
Barium also, right?
Barium is a metal or a non-metal?
Non-metal.
Non-metal.
No, barium is a metal.
Non-metal.
Barium is a metal, you guys. Barium sulfate, that is a metal.
Sulfur.
Sulfur is a non-metal, yeah. Okay, now like we'll just limit it at 4 because I need you guys to do one exercise here. Do you guys remember the electronic configuration for this? For all of
Yeah.
you. Yeah. I'll
Problem is
ma'am.
11.
how many of you remember it? How many of you don't remember it? Raise your hand or like talk about it, however. Aditya and Puneet remember it, okay. Rest of you don't remember it, no issues. I'll help you guys out with the atomic number. So sodium is 11, potassium is 19, magnesium is 12, and aluminium is 13. Oxygen is 8, carbon is 6, nitrogen is 7, and chlorine is 17. Okay. Aditya, electronic configuration for sodium?
8, 1.
2, 8, 1. Okay. Puneet, oxygen के लिए?
Miss 2, 6.
2 and 6. Okay, next. Anirban, do you want to attempt potassium?
Is it 2881?
Very nice, you got it. You do remember it. 2881 is absolutely right. Who's next? Who has a pyramid in their profile picture?
Ma'am.
Yeah. Electronic configuration for carbon?
Carbon, it's, ma'am, have you written 6?
Yeah, atomic number is 6, yes.
Yeah, so it's 2, 4.
2, 4 is correct. Neki, magnesium?
Ma'am, 282.
282 is absolutely right. Elena, nitrogen?
And 2,
2,
5.
yes. Who's next? Dhruv, aluminium?
2, 8, 3.
2, 8, 13 hai, so 2, 8 and 3. And Divya, chlorine? Divya?
Yes, ma'am.
Yeah. What's the
Yes.
atomic, the electronic configuration for chlorine?
Yes, I don't.
17 is the atomic number. So you can figure it out based on this. Like see all the pattern that happened here. Chlorine atomic number 17, matlab protons, and so electrons, number of electrons is 17. So how are they distributed?
Ma'am, 2
Yes.
and 2, 8 and 7.
You got it. It's absolutely right. Yeah. So these
Yes,
are the
I was confused.
so these are the electronic configurations, right? Now, can you find something like can you figure out any pattern between metals and non-metals?
For metals, it is 4 or less than 4. For non-metals, it is 4 or more than 4.
That's a
The
very
last
good
number.
property. That's very good observation, Neki. Yeah. So you can see metals always keep having less than 4 electrons in the outermost shell. Non-metals keep having greater than like 4 or greater than 4 electrons in the outermost shell. So what can you say about
Metalloids like have 2, 8, more than 10.
sorry?
Metals have more than 10 electrons.
Non-metals also. Like chlorine has 7.
Only one of them.
What is the atomic number of sulfur, Puneet? Any of you remember sulfur ka atomic number? Mansi, that is the mass of sulfur. That's the atomic mass. Atomic number is 16. Yeah. And phosphorus ka is 15. So yeah, that's on me. Like I took bad examples because yeah, it's like that. But yeah, that's not a common thing between metals, and it's not a rule that metals have more than 10, non-metals have less than 10. Koi bhi ho sakta hai. But yeah, the key point is in the outermost shell, what kind of valencies they have.
Ma'am,
Yeah.
Ma'am, so can one observation be that like metals can give the electrons like in the outermost shell to like attain an octet, they can give away the electron and non-metals can accept.
Absolutely. That's actually brilliant, Alina, because that is the whole reason that makes metals different from non-metals. Now, because metals have less than 4 electrons in the outermost shell, metals have a tendency to give electrons. And non-metals, because they have more than 4 electrons, like they can't, like chlorine can't lose 7 electrons, right? That's like a whole lot of electrons. So non-metals have a tendency to gain electrons. Okay, so that is the most basic difference between metals and non-metals. The property that makes metals metallic is the fact that they are able to give electrons easily, and non-metals tend to either gain electrons or share electrons. Like they cannot give electrons at all. Okay, so this means that metals can form what kind of ions?
Positive cations.
Yes.
Positive cation.
Correct. And non-metals can predominantly form what kind of ions?
Negative.
Anion.
Yeah. So this is like a sure shot way of identifying if something is a metal or a non-metal. So if it is capable of forming, like if it forms only cations, it is 100% a metal. And if it is capable of forming anions, if it gains electrons or shares them, if it can form covalent bonds, then it is 100% a non-metal. And metalloids again fall somewhere in between. sometimes they, like, depending on the situation, they may form like ionic or covalent bonds like that.
So, ma'am, metals are electropositive and non-metals are electronegative.
Absolutely. That perfectly describes, if you had to put this in one word, metals are electropositive. And non-metals, the tendency to attract electrons is called electronegative. Yes. Yeah. Again, describes the same thing, just different words. Electropositivity is the tendency to give electrons. Electronegativity is the tendency to attract electrons. Okay. And yeah, this is the whole reason of why is there a difference between metals and non-metals. So usually elements that have a tendency to give electrons will have properties of luster, sonorous, conductivity, all of that, and then we end up calling them metals. It's like that. Okay. Okay. So are you guys like noting this down?
Yes, ma'am.
Okay. So you won't be asked questions based on this, but it's good for your understanding, you know, like to figure out where is it coming from and all of that. Like you won't get direct questions based on this. So that is why if you talk about barium here, will barium be a metal or a non-metal?
Metal.
So where have you come up with barium before?
Barium sulfate, BaSO4.
From the salt.
Correct. And what sort of ion does barium form here?
Cation.
Cation, right? So cation matlab it's basically a metal. So let me know when you guys are ready, and then I'll show you guys, like we'll continue the next part.
Done, ma'am.
Done, ma'am.
So yeah, like when we talk about chemical properties also, keep in mind. So metals have a tendency to form cations. So all their reactions also will follow like that. Like because they form cations, they get attracted to the anions. Anyway, so that we'll observe when we do each reaction one by one. So before we get to the physical properties, like now that you know what makes metals metallic, so we'll see where their physical properties are coming from. Okay. Is this image visible or should I zoom in?
Invisible.
Better if you zoom.
Okay. Okay. So if I take a block of iron or any metal, actually block of sodium, any block of metal, elemental metal exists in this way. Okay. So you have each atoms of metal. So the positive thing represents the core, like where the nucleus is, where the protons, positively charged protons are. Okay, so each of the atom is nicely arranged in a block. Metals are usually solids, so they have like a rigid arrangement. They're not going to flow anywhere. Now, metals have a tendency to give away electrons, right? So the valence electrons that can get easily detached, so those electrons, instead of being fixed to the atom, they are all flowing in between the spaces of different metal atoms. Like the whole blue color cloud that you see, so that's all called, so it's called a sea of electrons. Because the whole negative charge, like negatively charged electrons are flowing in between the metals. And because these negatively charged electrons are loose and free flowing, That is why you can see that they can conduct electrons easily. So going back to electricity wala chapter, what is electricity?
Flow of electrons.
Yeah, if you take a pure metal, yes, it's flow of electrons, right? So electrons should have the ability to flow, and they have it in metals because they are just loosely hanging out in between the spaces. In non-metals, the electrons are fixed to those atoms, like they cannot flow like this, like with metals. Like non-metallic atoms can't give away those electrons freely. So that is the reason metals are better conductors and non-metals are not. Okay, and because of this, the sonority is also a result of this. How have you guys done sound chapter last year?
No, ma'am.
Oh, okay. Then that's gonna be difficult. What do you guys know about sound?
Like it is caused due to the movement of particles, vibration basically.
Ma'am,
Yeah.
it's like a wavelength. Sound is a
Sound is a wave, not a wavelength. Okay, but yeah, both of you, absolutely. So it is absolutely the movement of particles, correct? So when particles start vibrating, that's how sound is produced. And once they start vibrating, the way sound, like this starts vibrating, it pushes the air molecules beside it. This starts vibrating, this pushes the air molecules beside it. So that's how the wave is created, as Divya said. So yeah, absolutely. So that's how sound travels. So when you strike this metal really hard, like when you ring a bell and all that, all the particles start waving, like vibrating, and sound is produced. Okay? But because these electrons are still there and they're loose and free flowing, right? So it takes a while for the electrons to stop vibrating. So that causes, first you have the initial ping wala sound, and then the subsequent, like how the sound continues is because, like these particles are still vibrating. So even luster, the reason for luster of metals is because of these free electrons. So basically, when light falls on the metal, these electrons tend to observe some wavelength and then they emit it back. And yeah, that's causing the luster of metals. What other properties are there? Malleability and ductility. Okay, their ability to flow freely. There's this handy image. So originally, the block is like this. When you take a hammer and strike it, they're all held by these electrons, right? So the electrons are the delocalized, the free flowing electrons are basically holding together, this layer of atoms and this layer of atoms. And that's where your malleability and ductility also comes from. So the bottom line is that the sea of electrons, the free flowing electrons, are responsible for the metals being metallic. And these sea of electrons exist because metals have a tendency to give away electrons. They're electropositive in nature. Okay. Does that make sense, you guys?
Can you re-explain?
Yeah, ma'am. Can you explain?
Okay. So what part of it, like what part of it do you guys want an explanation of?
Second image.
Oh, the malleability ductility part. Lekin tab tak, why is it a good conductor? Why is it sonorous? वो सब समझ में आया?
Free electrons, right? Because free electrons are there, so they help in wave movement. So like stopping the wave movement and also conduct electricity to the free electrons. That I understood. That's the second.
Okay, so malleability ductility part you are not able to understand. Okay, I actually have a video here that would be better. So I am going to share this video with you guys. It will help with understanding it better. But the malleability, ductility part, let's see. Oh, there you go. Yeah, this is the animation that you have. So this is how it exists, okay? Like you have the positively charged cores and you can see the tiny electrons over here, the sea of electrons, mobile electrons that are just flowing over here. So when you hit it with a hammer, you can, if these electrons were not there, it would have just broken, like there would have been a crack and it would have just broken. But because these electrons are there, they are like always holding the things together. Okay. So that is the reason why, instead of breaking cleanly, they just end up bending, because these electrons are just holding on to the atoms tightly so that it's not like breaking apart. So that's where your malleability comes from. What I'll do is, end of the class, I'll share this video with you guys. You can like see it properly. Okay. Can you switch on your video at least? Like I'm not getting anything from you guys. Okay, but basically the bottom line is that one, metals are electropositive, like they can give out electrons easily. And so point two, because they can give electrons easily, it's like when you have a block of metal, there's always loose free flowing electrons in that block around the individual metal atoms. And three, because of the free electrons, all the properties of metals arise because of the free electrons. Yeah. So be it luster, be it conductivity, be it sonorous nature, be it malleability, ductility, whatever property you have, it's all because of the free flowing electrons in the metal crystal. Make sense? Okay.
Yes.
Right. Dhruv, Mansi, Neki, Elena, Devya, where are you guys? Okay. So starting with the chemical properties. Before we go ahead, like how did you guys find this chapter? Like a lot of you have already done it in school, right? You also done extract.
And we completed it yesterday.
So did you find it easy, difficult, confusing? It's all right.
Starting was like this is easy, but later it gets like little.
Extraction was difficult, but then it is
not easy also.
Then it is removed, right?
So the reactions part of it, all of you found it like relatively easy to medium sort of a thing, not difficult.
Yeah, because we just covered it in the previous chapter.
Extraction part was hard, but then it is removed. So it is easy.
Extraction anyway.
Like displacement reaction was easy.
Yeah, because
other things were easy.
Because
we studied that.
These things you already done it in chapter 1 and 2, so it's like repetition of it. Okay, cool. So coming to the reactions, okay, first we have anodizing. Anodizing, we will discuss in detail what it is, why it is, but the process is that anodizing is a process of forming a thick oxide layer of aluminium. This is very specific to aluminium only. Amphoteric oxides, this you guys should be able to Figure out,
Yes, ma'am.
because we already did it previous chapter, amphoteric metals, amphoteric oxides. Displacement reaction, also you guys already know about. We discussed it first chapter. Reactivity series, the order of reactivity. This also you guys have come across it. Ionic compounds. Okay, what do you mean by ionic compounds?
Give and take of ions between the compounds. Like NaCl. So Na gives one
Charged
electron
particle.
to Cl to stabilize it.
So basically compounds that are composed or that form due to attraction between ions, between charged particles. Okay, so these are like the basic definitions. Rest of it is all individual reactions one by one. The first one we have is reaction with oxygen. Okay. So how do metals react with oxygen? What products are formed when a metal reacts with oxygen?
Metal oxide.
Excellent. Cool. Reaction with oxygen first. Again, just like previous chapter, note down the reactions. So metal plus oxygen forms metal oxide. Yeah, that's it. Like nothing else basically. Okay. And some examples. Like for example, sodium plus oxygen gives what? Magnesium plus oxygen gives what? Iron plus oxygen gives what? Then copper plus oxygen gives what? We can basically do this for any metal, but just for practice. And these are like some special cases.
So we have to tell the answer like on mic, or we have to tell it on chat answer.
Send it on chat. Send it on chat. Because that way I'll get to see all of your answers. Yes, Mansi is correct. Okay. So this is basically a practice in knowing your valencies. Otherwise, pretty easy, like sodium oxide, magnesium oxide, iron oxide.
And for iron, which one should be considered, 2 or 3?
Consider 3. Anirban, nicely, like, yeah, sodium oxide, magnesium oxide answers have. I need the formula, like complete the reaction here. Mansi got all of them, yes. Puneet, check valency of sodium, huh? Otherwise, rest of it is all correct. सोडियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन भी लिखा है ना हमने अभी. Check it. Elena got all 4 of them correct. Oh. Puneet, yeah. Now we got sodium ka correctly. Divya, where did you get that reaction from? You simply had to figure out what is the valency of sodium, what is the valency of oxygen, and give the product. That's it. Neki, yes, all 4 products are correct. Anirban, you need to check sodium and iron. Okay. So Aditya, Dhruv, and Neki are yet to send.
Ma'am, I sent it earlier.
I didn't call out your name, right? Acha, aaya network issue maybe. And Neki, you also, kya? Oh, you, yeah, I. Yeah. Sorry. Elena also sent it. Aditya, can you send it again? क्योंकि अभी तक आया नहीं. It like, did you just send it 1-2 minutes ago, or has it been a while?
Ma'am, I sent it a while ago.
Oh, तो फिर से भेजो, अभी तक आया नहीं. I didn't call out your name also, right? Anirban, sodium ka, now you've corrected it. Iron, you need to correct it. Like oxygen ka valency kya hoga? So crisscross method, right? Dhruv, you missed out magnesium ke liye, and iron take +3 oxidation state, +3 valency.
Ma'am, did you get it now?
No, Aditya. Are you sending it to somebody else on private chat or something? Just check. Now I got it.
I sent it to by mistake to Dhruv 2 times. That is why it didn't get it.
Abhi aaya. So sodium oxide, magnesium oxide, iron oxide, copper oxide. Sare correct ho gaya. Nice. Anirban, no. So I'll work it out. I'll give the answer. So sodium, more or less, all of you have got it correct. Sodium always forms +1. Oxygen is -2. Crisscross karne pe, you get Na2O. Magnesium, this is straightforward, +2, -2. So dono cancel, okay, you get MgO. Fe and O2. So Fe, I asked you to take +3, oxygen is -2. So crisscross karne pe, what do you get? What number should I put? Fe and O. यहाँ पे क्या आएगा? यहाँ पे क्या आएगा? Fe2
and 3.
Yeah, so that's how you work it out, Anirban. Okay. And copper, again, all of you have got it right. It is.
Miss,
Yep.
Miss, like normally in iron there are like multiple valencies. So normally we have to take 3.
Normally take 3, like go for 3. In cases where you know that, okay, like iron sulfate ke case mein, it usually the one existing is FeSO4. So wherever you know a thing, you're familiar with it, take +2. Otherwise, go with +3.
Okay.
Now, special notes about it. Sodium is highly reactive. So if you leave sodium outside in the air, this reaction is going to happen spontaneously. Okay. Magnesium is slightly less reactive than sodium. Like sodium and potassium going to react like automatically. You just release them in air and it's going to change color. Magnesium, how does it react with oxygen?
Ma'am, it forms a white precipitate.
White salt substance. Precipitate, use
White powder.
So use the word precipitate only when you're doing a reaction in water. ये अगर dissolve नहीं हो रहा है तभी we call it a precipitate. Otherwise rest of the things it's like just white salt, white powder ऐसे बोल सकते हैं. Okay. So magnesium, you guys are aware of, like releases a lot of heat and light, and you need to burn it first for the reaction to take place instantaneously. Otherwise, if you let it, it's going to take like a few hours, maybe 1-2 days for the coating, like the magnesium oxide coating to be there. Iron oxide takes like lot of days. Like this is basically rusting. But it's very slow. Okay, so copper oxide also. So this is a popular question that you'll be asked about this. Okay. So copper, what is the color of copper initially? Copper metal?
Blue.
Huh?
No, metal will be brown. Copper metal will be brown.
Yeah. So it's like a brown kind of orange, like that metallic thing, right?
Brown color.
What was that, Nikki?
Slightly like bronze color.
Like a brownish, orangish, bronze color. Bronze is made up of copper. Yeah.
Ma'am.
When you burn it, the color of copper oxide is black. Okay.
Hydrogen is added, it becomes brown.
Yeah, and the reason for that, like the reaction that takes place is, if you have CuO and make it react with hydrogen, what happens is, again, displacement reaction happens. Like hydrogen being more reactive than copper can displace it, forms copper metal and water back again. So you add hydrogen, turns back brown again because of, you're getting copper back. Okay. So just make note of these colors because this can be like an application-based question that you'll be asked. Like a brown metal on heating in air. So heating in air, matlab, it's basically reacting with oxygen. So that's like a code word for reaction with oxygen. So on heating in air, turns black. On passing hydrogen gas over it, it turns brown again. So identify the metal, then you should know that it's copper. The black one is copper oxide, like on oxidation becomes copper oxide. So you can make a note of it side or somewhere. So basically, if the question says on heating in air, it means that whatever is being heated in air is reacting with oxygen. Even magnesium, you're heating it in air, right? Like you take magnesium ribbon when you're doing that experiment, you're heating it in air. What's that, Nikki?
We even say burning in air, right?
Burning in air, heating in air, yes. So after heating, like if it gives out flames, like heat and light and all that, you call it burning. But if it's not giving out heat, light, if it's not like bursting into flames, then it's simply heating in air or heated in air, whatever. Yeah. And usually another note you can make is this reaction is exothermic. So if it is highly reactive, and like in the case of magnesium, it is kind of moderate to high. Like if you just let it react naturally, you're not going to get a lot of heat, light and all that. But if you put it in flame, you're getting all of that heat and light. Sodium is like reaction with sodium, always, all the time, it's explosive, violent. Even in the case of iron, the reaction is exothermic, but you don't see fire everywhere because it is extremely slow. So whatever heat is being produced, it's being produced at a very, very low rate. Like the amount of heat produced is so slow that you don't notice it. But usually most of the reaction with oxygen is exothermic in nature. Let me know when you guys are done and I'll go to the next part.
Done.
Okay.
I just wanted to know, don't we balance them?
You need to balance, like goes without saying. Like right now, while I'm teaching, I'm focusing on the new stuff that I need you guys to note down and know about. But always goes without saying. That's why in your notes also, I'll always tell you guys, balance all the equations. Okay. Yeah, rest of it also, you can like balance it on your own. Balancing is like chapter 1 stuff. Like you guys need to keep practicing it. It always goes without saying. It's a default rule. Yeah, Aditya, you have your hand raised. Any doubt?
No, ma'am, for that one.
So like because metals react with oxygen, which is in the air, this leads to corrosion, right? Like iron gets rusted, copper gets dull and tarnished, things like that. But there is a special case, like in the case of aluminium. So aluminium, on reacting with oxygen, what do you get?
Aluminium oxide.
Al2O3.
Yes, both of you are right. So you get aluminium oxide, jiska formula hai aluminium Al2O3. Now, the special thing about aluminium oxide is it is stronger than elemental aluminium. Or let's call it aluminium metal itself. That's a compound. Okay. And because aluminium oxide is stronger than it, so aluminium does not corrode. Okay. So what happens is, I don't have gray color here. So imagine this is a block of aluminium. So this is like a metal. So metal is exposed to oxygen. So aluminium being one of the more reactive metals, starts reacting with oxygen. Yeah. So this is all aluminium metal, right? So once it reacts with oxygen, what happens is it forms, it reacts layer by layer, forms a layer of aluminium oxide. Now, because aluminium oxide is stronger than aluminium, it's like basically pretty strong. So once aluminium oxide is formed, aluminium oxide has like settled on the outside layer of this aluminium block or sheet, and it prevents any more oxygen from going in. So oxygen molecule, even if it hits the aluminium block, it just comes across aluminium oxide and there is no reaction with rest of the aluminium. Okay, so that is how aluminium oxide basically protects from corrosion. Are you guys able to get it? Make sense? Or should I repeat it?
It's making little sense. Can you once again repeat?
Yeah. So you have a block of aluminium here. Oxygen molecules are there in the atmosphere. When or how does reaction happen? When oxygen molecule comes into contact with the aluminium molecule here, right? So initially, like if you have a fresh block of aluminium, that's what happens. Like oxygen comes into contact with aluminium and it reacts. So when it reacts, it forms this yellow layer of aluminium oxide on the outer surface of the block. Okay. But aluminium oxide का special property is that it is stronger than aluminium metal. Like iron जब rust होता है, I don't know if you observed, but like you just rub it, like you take a sandpaper or something, you rub it, and then the rust comes off. And then again, fresh iron is exposed, that reacts with oxygen, that gets rusted, and then it becomes powdery and falls off, right? That does not happen with aluminium oxide. It is strong enough that it basically forms a protective layer on the surface of aluminium. So the layer of aluminium oxide protects the inside further aluminium molecules from reacting. Like even though the oxygen is hitting this, what it comes across is aluminium oxide first. It comes across the oxide layer first. So it can't get to, these aluminium molecules that are inside the aluminium block. So that is how the oxide layer protects aluminium from further corrosion. So it's not like breaking down like iron and other things.
Ma'am.
Yep.
Ma'am, I just had a question that when we use aluminum utensils at home, we burn them so many times, but then also they don't get even a dent on their downside. Why is that so?
Again,
They're
like
coated with something, no?
yeah, they're coated with a layer of aluminium oxide.
Oh.
Now, because aluminium oxide protects from corrosion, you don't have to put any special thing on them. Like you don't have to put paint or grease or any other metal or something like that. So simply what people do is, before this happens naturally, so aluminium is coated with a layer of oxide to protect it from corrosion. So this process is called, what is this called? Anyone remembers? So this process is called anodizing. Yeah. Okay, I don't know if you guys are silent because you're noting it down, or if you're not getting it, or like what's happening.
Yes, no, got
Yeah.
it.
Okay.
Ma'am, should we make the diagram?
Up to you guys. Like I made it because I wanted you to visualize it, explain it. If it will help you guys, make it. Otherwise, note down anodizing, that is sufficient. The main part is the definition of anodizing. Everything else is for your understanding. So if you already know about it, well and good. Otherwise, you can note it down. So if at all you're noting it down, write this as Al2O3 layer. So it's just one layer of Al2O3 which is protecting it from corrosion. So how anodizing is done in real life is it is done by electrolysis.
Done, ma'am. Right.
Done? Okay. Let me know when everybody is done, then I'll
Yes,
play a video of it.
Ma'am, 1 minute.
Yeah. Take your time, like note it down and then let me know, and then I'll change this.
Yeah, ma'am, done.
Okay. So 4 people. Okay, Neki is done, Alina is done, Dhruv is done, Mansi is done, Anirban and Aditya are done. Puneet is also done, Dhruv is also done. Okay. Cool. Yeah, there you go. This is like how the anodizing process works. So you can see like anodized surface, like if you put paint on something, paint can always come off, like you can chip it away, right? But with anodizing, you don't have that risk. Like that's an advantage. That's why aluminium things ke liye you preferred anodizing it. And this is how anodizing is done. Like you have these tanks where the aluminium things are inserted in a solution. Electrolysis is done, like you pass the electric current, oxidization reaction happens, and it's coated with a layer of oxygen there, like aluminium oxide there.
So before making them into utensils, they anodize the bars of aluminium, right?
Exactly that. I'll have to go into each industry to check it out. I don't know if things are created first and then anodizing happens, or if it's the other way around. But yeah, this is how it's usually done. So that here they're explaining the whole process, what happens. This is like an animation of the process. So first you clean it up because you don't want any impurities. And then you do etching, and then you do anodizing, and then you can do this thing. Now I'm not playing the audio. Like if you guys are interested, because this will contain, like this contains details of a lot of things that that you might not have come across. So if it's gonna confuse it, yeah, I don't want to confuse you guys further. But I just wanted to give you a visual of how it happens. Like you have these large tanks, and yeah, like it's cleaned, processed, and then you immerse it in the tanks, pass electricity through them, and then like get it oxidized there. That's how it happens.
Ma'am, what are those white stains?
Could be anything. It could be grease, it could be, during transportation, if something happened, it could be like parts of it chipped away, transportation damage. So that's what they're going to take care of first. In etching and in like cleaning part of it, they're going to take care of all of that. So it's like a 4-minute long video. They're going to explain it completely in this thing. So if you're curious about it, yes, you can. I'll send this also to you guys. You can watch it. But yeah, just letting you know, it might contain things that could confuse you. If you're curious about it, yeah, you can ask me and I'll answer. Okay. Okay. So that's like basics of oxidation. We've seen how metals react with oxygen. It's pretty straightforward. You have a metal cation, oxygen anion, you get metal oxide. Some special cases. Oh, metal oxides are basic in nature. Like we've seen that in the previous chapter also. Metal oxides basic in nature. How do you show that metal oxides are basic? What is the proof for it? Mansi?
Yes, ma'am.
Yeah. How do you prove that metal oxides are basic in nature?
I actually don't remember.
What is a property of a base? Like, what sort of reactions do bases undergo?
Ma'am, I couldn't hear you. Could you repeat that?
They're saying what sort of reactions will bases undergo?
Like you're asking the types of reactions.
Yeah.
Like bases react with non-metals and like that.
Yeah. Like essentially, how do you identify bases through a reaction? Like, Elena got it. That's absolutely right. I'll give you a hint. It's actually more of revealing the answer. So if bases are to be neutralized, what should they react with?
An acid.
Right. Now, if we are calling metal oxides basic, what kind of reactions should they undergo? Like should take place with them?
With an acid.
Correct. Neutralization with acid. So can you give me an example? Like if I tell you like metal oxides are basic in nature, prove it or show it with a reaction, or show the basic nature of metal oxide with a reaction. So can you give me an example of it?
With a base.
With a reaction. So if they're basic in nature, you just said they should react with acids, right? So give me an example of metal oxide as an acid.
Like metal oxide and an acid. So it would be sodium oxide plus sulfuric acid.
Okay. Gives
Na2SO4 plus H2O.
very nice. Again, so Mansi, if whenever anybody actually, if you're in doubt, how will a reaction take place? Figure out the cation and the anion. So इसमें cation क्या होगा?
Oxygen.
So yeah.
No, oxygen is actually minus. So sodium.
Sodium and oxygen is the anion. So इसमें anion क्या होगा?
H2 is the anion and SO4 is the cation.
कैसे? H like acid है ना? Will this give H plus or H minus?
It should give H plus, right?
तो cation कौन सा होगा इधर?
Cation is plus. I got confused at this point.
So H
Hi,
plus.
ma'am.
Hi, yes. And
Yeah.
so SO4. One moment. All right. So now can you predict the product based on this?
Yeah. 1 second. It should be Na2SO4.
Yes.
Plus H2O.
Yes. And what types of products are being formed? Like Na2SO4 is what kind of a thing? Like is it acid, base, salt? It's
a salt.
It is salt plus this is
water.
Okay, so when metal oxide is reacting with acid, you're getting salt and water. So what is that similar to?
neutralization reactions.
Correct. Okay. So that is how you can show that metal oxides are basic in nature. So just like bases, metal oxides also, when they react with acids, they neutralize the acid to form salt and water. Puneet, the message that you sent, NaOH is not metal oxide, that's metal hydroxide. Okay. So just be careful there.
Yeah, ma'am. I said an example of neutralization.
Acha, example of neutralization. So फिर ठीक है, that is correct. Okay. Cool. So that's how you prove that metal oxides are basic in nature with reaction. So you can take anything. Magnesium oxide plus HCl also you can take and you can show that way. Some metals form oxides that show both acidic as well as basic behavior. They're called amphoteric oxides. So this is something that you had come across. Over there, we saw how metals reacted with acid and base. In this case, it's the same reaction, except because you're taking metal oxide, instead of hydrogen gas, you get water. So that's the only difference. Okay. So note down amphoteric oxides, the definition and the examples, these reactions.
Ma'am?
Yeah?
Yeah, I had messaged you. I had gotten back for 2 minutes. Can you repeat what you've done after anodizing?
Anodizing ke baad, I was just summarizing this. We were looking at different like oxidation process, and yeah, we came across metal oxides being basic in nature. Like, how do you show that metal oxides are basic? So you do it with neutralization. Yeah, like you show that metal oxides also with acids, just like bases, they neutralize acids, and that's why you can say that they're basic in nature. Okay. Then we have amphoteric oxides, exactly like amphoteric metals, but instead of metals, you take metal oxides like aluminium oxide or zinc oxide. So note down the reactions also, because they're important to continue, like talk about amphoteric oxides and note down the reactions, equations.
Okay.
Okay. So let me know when you're done, and then we will continue this.
Ma'am, what do we have to note?
Amphoteric oxides. Note the definition of amphoteric oxides and these examples, like for aluminium metal.
Okay, ma'am.
Done. Okay, Elena is done. I think we'll stop after this part. So after this, we'll take up reaction with water. Then we have reaction with acids. We have displacement reaction and a bit about ionic compounds. We'll be done. Awesome. Do you guys have a date of when your school is going to inform you about the syllabus?
No, ma'am.
In our school,
My
they
school
told like 2 days something, 2 to 3 days.
They didn't give an exact date when the orientation will happen.
My school is given time.
Yes, Anirban?
My school is giving any day any subject syllabus. Like yesterday it gave Hindi and today it gave English, but there is no science system and no one.
Okay. And somebody else also was talking, right? Mansi, okay, mostly in a week. Okay. No, I'm asking because I kind of want to know, like, should I do extraction or